of the Unit 6 Geometry Test Review. We're going to start with transforming figure F by the rule negative x plus 2 and then y minus 4. So I like to make a table, so I'm just going to make that in this spot under number 2. Make a table of the original xy coordinates and then the new xy coordinates, which is going to be negative x plus 2 and y minus 4. So we can just see each original xy coordinate, just going to go around clockwise, 3, 4, then we have 3, 6, then we have 5, 6, then we have 7, 8, oh, 7, 8, what am I doing? 7, 4. Okay, and then we'll just take each value. So right here, the original x value is 3. We're going to plug that in for here. So we'll do negative 3 plus 2, which is now a negative 1. Same with the y values. We're going to do 4, and 4 minus 4 is going to now give us a 0. Then we'll do, again, negative 3 plus 2 is a negative 1, and then 6 minus 4 is 2. Negative 5 plus 2 is now a negative 3, and 6 minus 4 is going to be 2. And then negative 7 plus 2 would be a negative 5, with 4 minus 4 is 0. So these are going to be the new points for the new figure F. So you can just take a second and plot those. Negative 3, comma 2, negative 5, comma 0. So to describe the transformation precisely, we can see with this negative x that is somehow reflecting, and we can see that the figure reflects to the other side, and it reflects over the y-axis. So precisely say reflect over y-axis. We can't just say it's a reflection. We have to say what line it's reflecting over. Then what the plus 2 is telling us is it's moving right in the positive direction on the x-axis 2 spots. So then translate right 2, and then the y minus 4 is telling us it's going down 4 units. Okay, describe the transformation result in the figure that is congruent to the original, similar to the original, both, or neither. So a reflection in the translation, that is a rigid motion which results in congruency, but anything that is congruent is also similar. So this is both. Number 6, find the distance from the focus point F to the point 14, 10 on the parabola, then identify where the directrix would be located. Okay, you can't really see the x-axis, but this would be 1, 2, 3, 4, 5, 6. This point is 6, 4. So that means the point 14, 10 would be at right here, if we can't. And we can't see the directrix. We don't have an equation to know where the directrix is, so we are going to have to calculate the distance between the focus and the point 14, 10. But that's okay, because we can use Pythagorean theorem to figure that out. So this is 1, 2, 3, 4, 5, 6 units. This is 8 units. So 6 squared plus 8 squared, that's going to be 36 plus 64. This is going to be equal to 100. Take the square root of 100, that equals 10. So the length from the focus to 1410 is 10 units. That means because of the definition of a parabola that the directrix is going to be 10 units below this point, which means since this point it has a y value of 10, the directrix is located at the x-axis. And the equation for that is y equals 0. Okay, a quadrilateral has the vertices at 0, 0, 5, 0, 3, 4, and 8, 4. Show this quadrilateral is a rhombus. And yeah, so a rhombus. Rhombus, just to go over, is a parallelogram that has congruent sides and since it's a parallelogram, it's got to have opposite parallels. So in order to show that this is a parallelogram, we have to show that the opposite sides are parallel to each other, but that the sides are also congruent. So I'm just going to label each vertice as a letter, so that if I draw out a table and I want to talk about each segment, I can find each segment's slope to see if it's parallel, and I can also find each segment's length. So the length, so AB, then BC, then CD, then DA. And remember, it doesn't matter what order this is written in, our slope is either going to be positive if it's going up, negative if it's going down, or 0 if it's going sideways. So we can see from these two that it's going directly horizontal, so those two slopes are 0. We have no rides, so they're at 0. So AB has a slope of 0, CD has a slope of 0. You can also count and see that they're 5 units long each. The other two, though, we are going to have to see. So B, we're going to go up 4 and over 3, right? 3. And it's going to be a positive slope. So this is going to be up 4 over 3. Those are our numbers to be able to calculate by Pythagorean theorem what the length of that segment is. Since the square root of 25 is 5, then that length is 5. We can do the same thing here. Remember, left to right is going up. This slope is also 4 over 3. And by Pythagorean theorem, it's also 5. So this proves that, write out why this proves that. Since opposite sides are parallel, by their equal slopes, and all sides are congruent. On number 8, this one is a quadrilateral. That's all we know about it. We need to figure out what type of quadrilateral it is. So go through the same process of figure out what the slopes of each one is and what the distance of each one is. So label, make a table. AB. Okay, slope from A to B, we go down 2 over 2, or technically down 1 over 1. So that would be a slope of negative 2 over 2, which is negative 1. The length, well, let's do the slopes for all of them. Looks like DC or CD is the same thing. So we got that going for us. We at least know that those two sides are parallel. Oopsies. Okay, B to C, this is going up, so it's going to be positive, and it's going to be a positive one. Same thing with DA, that's a positive one. So we can see here that these two slopes are equal, so they're parallel. These two slopes are equal, but these two slopes are called opposite reciprocals, so these are perpendicular. And there's other relationships in there, but let's find the lengths. 2 by 2, so 2 squared plus 2 squared. That's going to equal 8, so this is going to be the square root of 8, which actually equals 2 square roots of 2. DC is 2 by 2 as well, so that's also going to be 2 square roots of 2. You can type that in the calculator, you just will need to keep the decimal pretty lengthy. So that's the exact. Okay, then 1 by 1, that's going to be 1 squared plus 1 squared, which equals 2. So that means this side length is square root of 2. Same thing with D to A, just square root of 2. So we can see that because slopes are opposite reciprocals, and opposite sides are equal, lines are perpendicular, creating a rectangle. Finding the perimeter of this quadrilateral. So perimeter is adding up all the lengths of the outside. So we're going to add up all of those lengths. We have 2 square root 2 plus square root 2, and I know it looks intimidating, but it's really not that bad. So we have 2 square roots of 2 plus 1 plus 2 plus 1. So this is going to be 6 square roots of 2 units, and you can type that in a calculator to see what that is. I don't have that on me right now. And the area is just length times width, so we just got to take one side and times it by its perpendicular side. That's going to be 2 square root 2 times square root 2, which actually is 2 times the square root of 2 squared, which equals 2 times 2, which equals 4. Since this is an area, it's got to be units squared. There you go. There is the last part of the test review.